Hi, hello everyone. I'm Patricia Moreira, and today I'm gonna explain to you our new launch, our new ingredient, which is Agen, our epigenetic modulation of youth. So before we go any further, what is epigenetics? So epigenetics, all our genes, they come from our parents, our mother and our father, and it is stored inside of our cells. However, it doesn't mean that if you have that gene specifically, that this gene is going to be expressed. It really depends on environment and habits. So if you the kind of food that you take, the kind of diet that you have, if you do exercise or not, and also the environment, so where you are, if you are in contact with too much pollution and UV radiation, for instance. So if we combine these two factors, we can explain individual differences and phenotypes. For instance, why do we have two identical twins that they have exactly the same genetic information, the same genes? However, they can be and they can age and they can show different kind of pathologies, for instance. So why is there this difference if they do have the same genetic information? It is because of epigenetics. So epi means what it's above epigenetics. Okay, so it includes all the modifications that will occur in the genes. Okay, and doing that, it can work as a genetic switch, like turning on and turning off all the genes. And for us to move any further to explain the epigenetic mechanisms, we need to understand the DNA and its structure. So we do have around 1.5 to 2 kilometers of DNA inside of each of our cells. So how can we store that amount, that big amount of DNA inside of our cells? Okay, because our cells are around the nuclei of the cell, it's around 2 to 3 micrometers. So how can we fit 1.5 to 2 kilometers of DNA inside within the nuclei of the cell? So we need to have a specific structure that can allow us to store this DNA. Okay, so actually here, this is the DNA double helix. So you know that DNA, it's composed of two strands here. Okay. And what it happens is that we have some proteins that are called histones. So histones are proteins that in which the DNA will pack itself. Okay, so it will be all around histones here in order to pack the structure. And by doing so, the size of DNA will be decreased, will be diminished. Okay, so all this structure here, that the stones, okay, in combination with the DNA that it's completely packed around its structure, it's called nucleosome. Okay, so the nucleosome here, what it's going to happen is that nucleosomes will be packed around themselves, forming coils, and these coils will be packed to form supercoils. And this is what we have in a chromosome structure. Okay, so this is the DNA and its structure. So we always store DNA as chromosomes, which are actually formed through the packing of DNA around histones, which are proteins. Okay, and for the gene expression, which is called as transcription, okay, we need the DNA strands to be open. Okay, so the double DNA helix needs to be uncompressed and open. Okay, and after that, and we can see here a chromosome, in which DNA is being unpacked here, uncompressed. The double helix opens up, and then there are some enzymes that will bind to one of the DNA strands and will initiate the gene expression, which is called as transcription, because I will read the recipe, the ingredients in the DNA, okay, and transform these into a transcript, which is called messenger RNA, okay. So anything that modifies or the stones or will influence the packaging of the DNA can regulate transcription or gene expression, okay. So what are the epigenetic mechanisms that can interfere in this gene expression? First are the stones. So if I do have more stones or less stones available, I can influence the packaging of the DNA. Also, if I modify these stones somehow and I interfere the balance and the connection of the DNA with the stones. Also, if I methylate DNA, and we're going to see how these can interfere gene expression. And another mechanism, which is really well known, it's the non-codifying RNA, and we're going to talk about this in a bit. Okay, so the first epigenetic mechanism that we were talking about are the stones and the stones modification, right? So if I have more stones available, what is going to happen? I will, of course, I will favor DNA packaging. And if DNA is packed, I have less gene expression. I have less transcription, remember? Because I do need the uncompressed DNA and an open helix in order to have the gene expression. Then other things, any modifications on the protein, so on the stones, like if I add an acetyl group or a methyl group or a phosphor group, any different modification will alter this interaction. So tell me, if you think I have one more group added into here, into the stones, what will happen? Let's just take as an example, acetylation. If I do have one acetyl group that it's connected to stones, my DNA will be much more looser. Like it will not be packed, right? So if I remove the acetyl group, if I disacetylate the stones, my DNA will be more packed, right? So what happens if my DNA is not packed? I have more gene expression. And what happens if my DNA is more packed? I have less gene expression. So everything that alters this, it is considered epigenetic mechanism. Okay? So as we age, acetylation, for instance, is upregulated. So I do have more gene expression. So you may consider, okay, if I do have more gene expression, this is good, right? It really depends on the kind of genes that you are upregulating. For instance, you can have oncogenes that are upregulated in this case here. Okay, so genes that are bad, that are not supposed to be expressed. Okay, I can have also genes that are related, for instance, with the destruction of the extracellular matrix, so that I speed up aging. Okay, so but what is the problem with this epigenetic mechanism? Okay, actually they happen in a random way. Okay, so there is no way that we can control which area and which histones I'm gonna modify. Okay, so I can modify stones that are near genes that are good, or I can modify histones near genes that are not so good. So it's completely random, and I cannot control how this mechanism happens. Okay. On the other hand, DNA methylation. So what happens here is that I add a methyl group, okay, and I connected this to the DNA strand. And this is normally done in a promoter region. So how can I know where the enzymes for the transcription, the gene transcription, needs to connect? Okay, there is a region before each gene which is called promoter. Okay, so if I have a methyl group that it's connected there, there is no way that the enzyme will be connected to the DNA strand and start the gene expression, the transcription. Okay, so, but as we age, DNA methylation is decreased. Okay, so when we are babies, there are a lot of methylation in some of the genes. Okay, but as we age, we are losing the methylation, and so we start gene expressions. But again, I'm starting gene expressions of not so good genes, like oncogenes, for instance. Okay, so genes related to cancer or many other diseases. Again, here, why this epigenetic mechanism is not good to work with? Because it is random, okay? I cannot control which gene or which promoter region of the gene I'm methylating or removing methylation, okay? This is a random process. And then we have the non-codifying RNA. So what does it mean? Okay, we have a non-coding RNA, which means that, for instance, here you have the double helix of the DNA. On blue here, you have the gene. Okay, so once I start the gene expression, the transcription, I will create the messenger RNA, the mRNA. Every RM messenger RNA will form a protein, okay, and this protein will have a cellular function. However, other areas of the DNA that before it was known as junk DNA because it did not codify a protein, it did not codify a messenger RNA, okay, so this junk DNA they discovered, it was around I don't know, 6 to 7 years ago, they discovered that it's not too junk. I mean, it codifies something, okay? So these non-coding DNA, these areas here between the genes, which were supposed to be non-coding a protein, okay, does not produce a protein, but they produce a microRNA, okay? So it's a smaller portion of RNA, and it's non-coding, which means it will not form a protein. Okay, and what happens with this microRNA? This microRNA connects to the messenger RNA and avoids the protein production. Okay, so microRNA will always silence the production of protein. Okay, and the transformation of the messenger RNA to protein, it's called translation, okay? So the translation into protein, it's avoided, it's blocked. Nowadays, it's around 800 microRNA that are already identified, okay? The scientists, they think that it's going to be around 1,200 microRNA. And of course, this is a very interesting epigenetic to work with because we know exactly these 800 microRNA, we know exactly which messenger RNA they connect and which protein translation they will block. Okay, and as we age, microRNA are upregulated, so we're gonna have a down regulation of protein production, the translation of protein. So when using epigenetics in favor of youth, okay, so as we mentioned before, the messenger RNA will be connected with the microRNA, and then protein expression will be downregulated, and we're gonna favor aging processes. However, when Agen will downregulate microRNA that are specifically connected to aging, okay, and then we're gonna upregulate protein expressions that are good for youth, and because of that, we're gonna be younger. Okay, so these are mainly the problem and the solution for the epigenetic of aging. Okay, so Agen, it's the synergistic combination of apple extract and a supercritical ginger extract. And why we had chosen these two plants to work with? Because as you know, there are some old say that says an apple a day keeps the doctor away. And probably this diet that it's based on apple, it is probably related to epigenetic control of health, as well as the ginger, which it's basically used in a diet of the population that has more centenarian, the Asian population. Okay, so we believed that these two components could work really well on the epigenetic control of aging. Okay. And in this case here, guys, just for you to know, we used canola oil because the Malus domestic fruit extract, the apple extract, it's water soluble. The ginger extract, it's oil soluble. We needed something to combine these two ingredients. And also canola oil, in this case here, it is in there to enhance also permeation and the effect of these two extracts. Okay. So just to start the ex vivo studies for the microRNA, we did this on a fragment of skin of 45 to 60 years old. We applied a formulation with 1% of Agen, 24 hours of incubation, and we did array. What it is actually? If you consider a sheep in which I can screen several microRNA at the same time. So instead of doing the evaluation one by one, here I have a sheep in which after the incubation period, the skin is completely destroyed, and then I can collect microRNA and I can see which one are up or down regulated. Okay. So actually, these are the results that we obtained. We screened around 300 microRNAs related to aging, okay? And we could see here that Agen regulated or downregulated 5 microRNA that are most important and are related to these proteins here. So the AGF-R, which is the epidermal growth factor, very important for proliferation of keratinocytes, differentiation of keratinocytes, also proliferation of fibroblasts and production of extracellular matrix. So we can see that Agen downregulated the microRNA in 2 of them, one in around 60% less, and then the other a little bit over 70. Remembering that microRNA blocks protein production. So what we want to do in this case here, it is to downregulate these microRNA. Then we have collagen type 1 as all of you know, the dermis, it's composed mostly 70% of collagen type 1, so it is very important for the elasticity and firmness of the skin. Collagen type 4, here we have 3 different chains. We have chain 6, 4, and 3, which are, as you know, collagen, they are a triple helix. So they are formed with different chains depending on the place of the body that the collagen is being produced. And in this case here, collagen 4, it's also within the dermis, but it's very important for the basal membrane. The basal membrane, it's where the basal cells, the layer from the epidermis, are anchored. Okay, so for the resistance of the skin, the basal membrane are very, very important. Okay, then we have decorin, which will help the formation and stability of collagen on the extracellular matrix. And we can see here that we are down-regulating the microRNA related to decorin as well. And then fibronectin. So remember that I mentioned that the basal layer of the epidermis is anchored into the main basal membrane. So the anchor protein here, it's fibronectin. Okay, so we want to have more fibronectin so that the cells are well attached to the basal membrane, and then we improve the resistance of the skin. Okay, so we also are downregulating the microRNA. And then we move into, again, ex vivo. So I'm talking about the skin, okay, fragments of skin. But in this case here, 72 hours of incubation. Why? Because I'm looking into the protein levels, okay? And just for you to know, the control and the placebo formulation. And in this case here for collagen type 1, so in blue you have the nuclei of the cells, okay? So this is a counter staining with TAPI. And on green, you have the collagen type 1. This is a immunohistochemistry, okay? So with a specific antibody for collagen type 1. And it lights up in green. So when after 72 hours of incubation with 2% of Agen, we have an upregulation of collagen type 1 of 136%. With collagen type 4, the one that it's also within the dermis, but also on the basal membrane. And we can see here an upregulation of 45%. So this test just confirms that Agen, it's actually downregulating the microRNA, and because of that, we upregulate the protein levels. Here on decorin level, the one that stabilizes collagen, we can see here the control and placebo, and with Agen we have 138% upregulation. With fibronectin, the protein that anchors the basal cells, the basal layer into the basal membrane, we have here 102% up regulation of this protein. But we move forward, okay? In this case here, we analyzed the fibrillin. Fibrillin 1, it's also very important for the stabilization of elastin, because we know that extracellular matrix, it's composed not only of collagen, but elastin, that it's very important for the elasticity of our skin. So, and fibrillin 1 helps the elastin stabilization as well. And we can see that Agen also upregulates fibrillin, as well as fibrillin 5, which is also another molecule that helps to stabilize the elastin. Okay, so we can see here that Agen upregulates these protein levels as well. And then EGF, so the epidermal growth factor, we can see the control and the placebo. And then after 72 hours of incubation, we have an upregulation of more than 230%. So this is amazing results, guys. So then we move into the clinical studies. So the first, we performed 2 different studies for Agen. The first study, it was a panel with 44 women from 40 to 60 years old with wrinkles and signs of aging. We evaluated 2 products, the placebo and a product containing 2% of Agen. We applied the product twice a day for 56 days. And then we evaluated on day 14, 28, and 56. And we performed 3 evaluations on this panel, okay? So the cutometer to evaluate elasticity and firmness, the ultrasound to evaluate thickness. So if we stimulate, of course, proliferation of epidermis and better extracellular matrix production, we will have a thicker structure. And then we evaluated the skin tone on Visia, by Visia, okay? So the cutometer studies here, we can see that the placebo, through all the days, we can have here some results. However, it's not significant, okay? Not for firmness, elasticity as well. But when we move into Agen, we can see here an interesting result of 90% of firmness in 56 days and 16% of increase of elasticity. And these are significant results, okay? Also on the thickness results, what we can see here, it's that placebo does not change the thickness because, of course, it does not interfere on proliferation and extracellular matrix. Okay, so we can see here that after 56 days, there is no change on the epidermis and dermis. But when we look into Agen, we have an increase of 40% of Agen on the 56 and 29% on the dermis thickness. Okay, and on the skin tone here, we have a decrease, an improvement on the skin tone for the placebo, that it was not significant, but after the application of Agen, we have an improvement of almost 5% here. However, all these data that I'm showing, we are working with the average data, okay? Because this is how Communion works. We are always evaluating the average data. However, we know that some of our main competitors in the market, they use the best results that they obtained on the clinical panel in order to promote their product. Okay, so Agen, you're going to find in the literature and in the presentation the best results for some of the main parameters. Okay, and in this case here for skin tone, we had our best result. It was an improvement of the skin tone on 22.4%. So here I'm offering you 2 options. Okay, from the scientific point of view, of course, the best way to use it's always the average data. However, you also have available the best results. Okay. For the second study, we have 22 women, 45 to 65 years old, with wrinkles as well. So the same products, but here we evaluated for 90 days. And in this case, we evaluated wrinkles by Primus and also Visia CR in order to obtain a standardized pictures and documentations. Okay, so these are the results of Visia CR. So we can see here on day 0, one of the patients. Okay, so we can see there is a interesting decrease on many of the wrinkles around the eyes here. And also you can see a difference on skin tone. Remember that we are acquiring all these picture through Visia, which it's a standardized way, so there is no light interference here, and there is also no Photoshop. So we can see there is an improvement on the skin light tone. Another patient in which we can see here a very good result on the wrinkle here around the eyes. And a third example in which we have a very good result on the wrinkles. Then the primals, okay? So here you have here a scale. So the more blue you have here, it's the more deep is the wrinkle, okay? So here it's just one of the piece. You can see here a deep wrinkle that after 90 days, this wrinkle it's almost gone, okay? Another example here in which we can see many wrinkles here, and then the wrinkle almost done as well, okay? And then we went to the objective analysis, okay? So in these analysis with primals, we measure 3 parameters. So the SQ, which is mostly the average roughness, so it stands for texture of the skin. The S max, which is the maximum depth of wrinkles, and then the SZ, which is the average depth of wrinkles, okay? So these are the results of the placebo, and we can see here that you have a little bit of result in the texture. However, this is not significant, and of course, if you apply any product on the surface of the skin, the texture will be improved, okay? But then we have Agen results, which it's very consistent, and we can see a decrease of 12% on at least 12% in all the parameters. And again, here we are these are the average data, but the best results that we got for texture, it was an improvement of 32.4, and the best results that we got for wrinkles, it was 31%. Okay, guys, so you have both data in here available. So the benefits, just to wrap up, so we regulate epigenetic pathways of 5 essential microRNAs, reducing the appearance of signs of aging. We improve skin firmness and elasticity after 14 days. We redensify the dermis in 28%, and we improve the thickness in the epidermis in 40%. We improve skin tone uniformity, reduce wrinkle up to 31%. We improve skin resistance, integrity, and regeneration. And of course, we stimulate cellular renewal, differentiation for a younger and healthier skin. So Agen should be added into the oil phase of the product between 75 to 80 Celsius degrees. We had tested higher temperature, but temperatures above 80 Celsius degrees, it oxidizes the ingredients, so we do not indicate higher temperature than 80, okay? pH as well, we tested lower and higher pH for this product. However, we indicate pH of 3 to 7, in which there is no oxidation and there is no interference with the performance of the product, okay? And this should be added into emulsions and serums. We do not indicate these in oils because as we have one part that it's water soluble that comes from the extract of apple, what it's going to happen is that you're going to have a precipitation of the water soluble part of Agen, okay? And then of course you do not have the same performance. And the concentration of use that we have, it's at 2%. So I hope with that I finish here the presentation, and I hope we can do great, we can have great business opportunity with these ingredients. So see you next time. Thank you. Bye-bye.